Hi everyone, welcome to today's lecture on regular expressions and how we use them in Unix. So regular expressions are a way to specify a pattern, some particular pattern in a string. And from our purposes here, we're going to be using this pattern to find particular results that we're searching for. Regular expressions were invented by Stephen Kleene all the way back in the 50s. He was a very good guy, very fun guy. He was able to produce these regular expressions and find immediate use for them even before personal computers really took off. Nowadays, we use regular expressions in lots of Unix programs. We use them in grep and sed and vi, lots of different editors. So it's used extensively in Python and Perl. At least at OSU, we have an entire course, CS321, that covers these regular expressions and the theoretical underpinnings behind regular languages and grammars. So from our purposes, grep is really where we're going to start. So grep is one of the famous commands in Unix that's a bit inscrutable. It's a little hard to understand. So today I'm going to try to make this clear for you. So what grep does is it searches the input that it has for an occurrence of a string that matches a particular pattern. And it returns all the lines from the input that it receives back to you that match that pattern. So if I have a file here called file to search and I cat this thing out, then I can see that it's got a bunch of different lines in it. Each of them have this find me in all caps in it, except the fourth, which is a 3, and the fifth, which doesn't have it at all. And then the sixth is in the middle of another line. So cat that whole thing out. I can use grep here and specify the string that I'm looking for, and then I can specify the input that I want it to search through, which is a particular file, and it will filter out the lines that match from that file. So we can see that it avoided the fourth line and the fifth line. Pretty easy. So another example here, this time we are running grep where we are passing data into grep through standard in. And when we do that, we don't have to specify the input location that it should look at because we're passing the data in via standard in. So here I'm going to run the ps command to get a list of all the processes that are running on the system, and E and F will generate a huge list of all the processes running across all users, and F will give me the long form of each of these. But I pass this thing through into grep searching specifically for my name, and it will return only those names that have it will return only those lines that have my username in them. So we can see where the SSHD daemon is started up for my particular connection for my username run by root. We can see all the different processes that I'm using that contain my username in them as well. So in terms of operators that are used by regular expressions, the asterisk matches 0 or more of the previous character. And this is a little different than how we use the asterisk on the command line, where it just expands anything from where it is. This one here is matching specifically the previous character, including it will even match something where there are 0 of them. So this is known as the Kleene star, after Mr. Kleene, who invented this whole thing. So the circumflex is the technical term for that little caret symbol above the 6, or the hat, you might have heard it called. The circumflex, when it's placed at the beginning of a regular expression, indicates that the regular expression has to begin, it has to start at the beginning of the string. So it's a way to anchor the text that you're searching for to the beginning of that string. The $sign is, when it's placed at the end, matches the end of the string. And again, we've seen this before from VI, from the commands that are in there, which gets its terminology and characters from ed, where the $sign refers to the end of a string. And in fact, the circumflex command stroke, if you push that in VI, it takes you to the beginning of the line. Now, the 0 key takes you to the true beginning of the line, all the way to the left side in VI, but the circumflex takes you to the first character on that line. So it'll come in from any tabs or white space you have. So the asterisk matches 0 or more. So some examples of that. If I have a capital A and my pattern that I'm looking for is a star here, then that is going to match any of these strings that occur in the input that I give it. So the capital A itself will match. That's because the asterisk says 0 or more of the previous. So that's from this point on. So here we have A with 0 more additional A's after it. So that certainly matches. The next one here is a capital A followed by 1 more additional A after it. And here are 3, and etc. Here, A, B star, we are separating out the A with a new character B. So this is saying I always want my strings to match where the characters are A, B, and then 0 or more of the following. So AB followed by any number of B's after them. So certainly AB is matched because here there are no more B's after it. And then from then on we see B's going out. If we look at the same find me pattern we were looking at before, the asterisk at the end here is indexing off of the E, the capital E. So find me is matched, find me with 2 E's, find me with 3 E's, those are all matched. Not as opposed to find me, find me. So it doesn't take the entire 6-character sentence and replicate it into the, on to the right. It's matching only the previous character. So if we want to bind this to the beginning and the end, here's some of our examples for the circumflex and $sign operators. If I use just the characters JON, I match a string that contains JON anywhere, and capitals matter. If I put the circumflex at the beginning, this will match any string that starts with ABC. Capital X, Y, and Z with a $sign at the end of it means that will match any string that ends with X, Y, Z. And Ben Brewster itself with circumflex and $sign at the beginning and end is going to match strings that match that exactly, because I'm specifying only the string starting and ending with these characters. So it has to be exactly that. So the period operator here is going to match a single character. So unlike the asterisk, which is able to do 0 or more, the period just says any single character at this point in the pattern. The backslash we are going to use to tell the system here to not think of it as a control character, but just simply be the character itself, like the period. If you want the period to actually be located in the text, then you have to backslash escape it so it can actually be matched itself. So if we use square brackets, that means that we are matching any one character inside the brackets. So it's only any one character, and you can specify which of the possibilities of the characters you want by enclosing it all in square brackets. The circumflex operator gets overloaded here. When we put it inside the square brackets up on the left side, that means that this at this point in the pattern will match any character except any of the ones inside. And any other non-special character just matches itself. So here's an example of that period operator. Again, here's our same file to search file. Then I'm going to use my grep pattern, but this time I'll use the dot in place of a capital E in the pattern that I pass into grep. This time, the 4th line gets returned because we've said, sure, I'll take capital E's or 3's. Either way would be fine. So we get 5 lines returned this time. Here is a example with 2 different asterisks being used here. So here's a new data file. This data file contains a bunch of gibberish strings. When I use grep in this manner, I'm using both different asterisk types. So the pattern inside this string, the first argument that I pass to grep, this is a regular expression asterisk. So I've got my dot star, and this means match any string of any length, because the dot matches any one character, and the asterisk says any number of times for that operator. So this will let you return anything of any length. On the right side, the second argument is where grep should be searching, right? So before this was a file name, but here I'm saying any file in the current directory. So that asterisk is not the clean star. It's not saying any character before. It's not referencing the forward slash here. It's referencing files. This is asterisk file name expansion being performed by Unix. This expands to all files, which are then passed in as the space that grep should search through. When I run this command, it's going to return the lines from every file in that current directory. So here's the lines from my file, and then ... because all the other files also get their contents dumped here. Okay, so our backslash example. So the backslashes cause those regular expressions to literally interpret the special characters. So just to reference that, if you want to, or just to give an example of that, if you want to show a period in your pattern, you have to backslash escape that thing. Same for $sign, same for asterisk. Here are some brackets examples. Here's our file to search file again. This time I'm grepping it and I'm using the brackets to say match any character, any one character inside here. So either a capital E or a 3. So this is more limiting than the single period operator that we did before. That would have matched anything. This one specifically will only match the capital E or the 3. So we do get the fourth line returned. A second example here, this says match anything, any one character here except a 3. So we're explicitly excluding the fourth line because that ends with a 3 at the end of the find me construction. So that line will not be returned at all here. This example is saying find in the input space, which is the file to search, look for any pattern where in that string there is characters that are not a 3. So we have the fourth line get returned, even though it has a 3 in it. The reason is because there are lots of other characters on this line that aren't 3, which cause the pattern to successfully match that entire line, and it's returned by grep. So a little bit complicated there. We can also overload that square brackets. We can specify ranges of characters to match. So in this case, we're saying match any character in here, but instead of specifying the single characters that would be valid, we are saying an entire range of them. So if I use lowercase a to lowercase z with this hyphen operator, we'll match any of those characters in there. Now the ordering here is defined by the ASCII character set. So you could go, say, from lowercase a to uppercase q. But what does that mean? What's in between the lowercase and the uppercase sets? Well, that's defined by the ASCII character table. So here's a good ASCII table that I like. So in this pattern down below, we've got match anything here except the characters A through Z on the lowercase side. Very case sensitive. The OR operator will let us refer to one of a pair of options. So in this new file we're going to use, which is called cats and dogs, it has 4 lines. I like cats, I like dogs, I like cat dogs, and I like dogs. When I grep for cat or dog and tell it to search inside cats, dogs, it returns nothing. And that means that nothing matched the pattern that I just gave it. And it turns out that you have to escape that operator. So before, we were doing things where we had to tell it specifically to escape a period so that it would actually be returned as a period. In this case, we have the opposite. We have an operator, this OR operator, which by itself is normally used as a character. And if you want it to actually be used as a special character, you have to escape it. So that inconsistency drives me nuts, that you have to escape this one, but not the other. Anyway, when I say match anything where it says so this line says match any line that contains cat or dog. So I like cats, I like dogs, I like cat dogs, and I like dogs all get returned because they all contain either cat or dog. The next one here, we can put this in the middle of a string. So before, this was just the only pattern I was searching for. But if I want to be more specific and say, I like cat dog, and I want to specify that I like, and then the spaces in there come first, I have to put parentheses around it all. And I have to escape each one of those also to make them have effect. So it starts to get a little complicated with all those backslashes in there. To match a repeated pattern, we can search for a pattern that's repeated at least once. So here's a way to do it. If I have my file cats dogs, I can say grep and then enclose the single term in parentheses and then use \1. And we're going to talk about what this means in a minute, but the effect is going to be look for anything that has dogs and then repeated once. So here the only line that matches is I like dogs. So we're saying grep for any pattern that's dogs repeated once, and that's the only line. Curly braces are going to specify the number of repeats, at least, that we're looking for that will count as a match. So here's a new file. This one is called digs, and dig consists of 5 lines where the word dig, we got the line dig more and more on each line. So I am specifying that I want to grep for any line, return any line that consists of the word dig repeated at least 3 times. So see all the backslashes to escape all these characters, including the curly braces. But it does work. We're able to return dig as the lowest number of digs on a line returned. So let's look at what's called a back reference. Back references are really complicated ways to refer to previous matches that we have captured. So what the parentheses operator is actually doing is it's capturing a matched string that we can refer to later. So we were referring to that matched string with the curly braces by asking for a number of repetitions. But what that \1, \2 is actually doing is it's specifying that the string should match the nth pattern that we've previously captured. So the 1th pattern or the 2th pattern, or whichever one, the first or the second pattern. So in the example we had before, down here in my bottom example, where we had dogs and then \1, what that really means is capture dogs for use later, and also match it now, but then refer to that as a repeat later. So yeah, it's repetition, but really what it's doing is getting 2 instances of dogs. In this upper example here, we have a file called likes, and like consists of 2 lines, you like you and I like you. In my grep pattern, I say I parenthesize you and then say like \1, which is a reference back to the first capture of you. So this is going to match lines that only say you like you. So then, sure enough, the only line that's returned is you like you. Now let's switch gears for a sec here. So yes, grep is going to do great things for us in filtering out lines and finding things, but can we find things using grep itself? And if that works, are there other tools actually built into Unix that will do a better job or a different job finding things? Well, let's look at the grep way of doing it. So when we're using grep directly from the command line, i.e. we're not passing data in from standard in, we have to give it a specific place to look. So you'll see that here at the end of this grep command. The tilde says, look everywhere from my home directory. Now the R switch that I pass into grep says, start from where you are and go from there and deeper into all the directories. So recurse down into each subdirectory. The N says return the line number of all of the matching lines that you find. So when I say grep -rn for dogs starting at my home directory, it will search all of the directories that I have starting from my home directory and down, and it'll look inside every single file until it finds lines that match the pattern. And in this case, my pattern was dogs. As we saw before, that line exists in the file catsdogs, which is deep down inside some temp.dir grep test stuff, and I see that it is on line 4. So a handy way to find not only the file that it occurs in, but what line it is. This is a really powerful command as you are writing your own test scripts, as you're writing your own programs later on. You can't remember where you did something. Use this grep command to go find where it is. The find command is actually built to find files, and you can specify that it finds things in lots of different ways. So here we're going to specify that we are looking for a file by name, but you can have it refer to other things as well, like find files of a particular size. So we can also execute commands against the files that are found, which is a little bit nuts, and we'll show an example of that here in a sec. This example is one of the few that I want you to just straight up memorize. So this, like the one that we did on the previous slide, is how do I find a file based on the name of that? I know I've got it somewhere in my file system, but I can't find it. Where is it? This is how you do it. With the find command, the first argument there is going to be the place it needs to look, the place it needs to start looking in. So I'm going to give it my home directory. And recursion into subdirectories from there is implied. You don't have to specify it with the R character like we did with grep. So here I'm just saying find starting in tilde and down on, and use the name version. So find things by name. And the name of the file that I want you to find is the next argument, so digs in this case. So when I run this thing, it will start looking into a ton of different files until it finds it. And here it is in temp.dir grep tests digs. Now I want to bring over my command prompt here and show you what actually happens when you execute this command, because I have I've cleaned it up a bit here so that on the slide I've cleaned it up so that it won't be too dirty. But here's what actually happens. So I'm gonna here's my prompt. If I run this command, find tilde by name digs, then it returns a ton of stuff. I get all these permission denied entries, And these are happening because I've got files where you don't have the permission to go into them and look at it. So I don't want to see all that ugliness on the screen, because the actual one that I wanted is at the top, is this tempdir command. So the way that I can fix that is at the end I can say take anything that's going to standard error. And standard error is where all of these permission denied results are being written to by the find command as it runs. And I'm going to take anything going to standard error and I'm going to redirect it to a place called dev null. Dev null is like a black hole. So I'm basically saying, don't show me any of these error results. Put them into a black hole where I don't care about, and now run it. This is the command that will actually return just the file name that I want without any of the error results. All right, back to our slides here. Here's another example. This is the one where we are going to find stuff and then do something about what we found. So a little bit terrifying and something you want to be careful of. In this case, I am going to find wherever this file is called digs, and however many times it occurs in my file structure, and delete it. So I don't know where it is, but wherever it is, I don't want to be bothered to have to cd into it and rm it. I want you just to delete it wherever it is from wherever I am. So at the beginning, here's my find tilde by name digs command. So this is just going to find it starting at my home directory and for any subdirectories. Then I use the -exec option to indicate that I'm going to execute a command against the files that are found. For those that are found, here is the rm-i, and rm-i is saying that I want to delete that file, and the -i says ask me about it. So don't just blow it away, be careful. Then I have to use curly braces with single ticks around it to say do this command against all the files that get found. And then a semicolon at the end, which has to be escaped, which terminates that rm command. So when I run this thing, it will go out and find that digs file, and it'll ask me if I want to remove it. And it says, are you sure you want to remove this? And then I type yes to make sure it actually gets returned. So in the example we had before, where it gave me all of these error results about other files, and it's got all this permission denied stuff, those files shouldn't occur or I shouldn't see those as possibilities for deletion because they weren't actual hits that find was returning. So if I type this thing in and say find by name digs exec rm-i, here's my curly braces, and here's the backslash semicolon, hit return, it's going to say, do you want to remove this file? And I'm going to say, no, I don't actually want to delete that file. And then the rest of it I was never prompted on to delete. All right. So this example here, if we want to do a find based on regular expressions using the find command, then we have to indicate that by saying -regex. Now that's implied in grep. You're always doing regular expressions when you're using the grep command. But if you want to do that in the string that you pass to find, you have to indicate that with the -regex switch. So here I'm saying find anything that contains fork in it. I don't care whether it's in the middle, or wherever it is, find it. So at the beginning, whatever. And then whatever the result is, pass this thing through sort so that I get them back in file names that are sorted. So I run this thing, here's all the different testing programs that I've been writing as I go through these lectures that contain the lowercase word fork. As our final slide here, there's another tool that you can use in Unix called locate, which will find files using a database. And I don't recommend using this one. Despite the fact that it's faster, the reason it's faster is because it doesn't actually search for your files. It doesn't go through your hierarchy looking for that stuff. It builds up a database at periodic times of all the files that you have and stores that somewhere, which means that it's incredibly fast because it just consults its database for the particular file and then returns those files from there. But that means it's going to be outdated since the last file location check. And typically, the locate crawler that goes through all your files to index them all doesn't run all that often. I think it's like once per day, something like that, once per hour. Even once per minute could be too slow for me when I'm editing files, creating them, and changing them, and can't remember where I was. I don't have time to wait for this thing to index all of the files again. And it's not even available on every system. It has to be something that's specially installed. And for those that do have it installed, it behaves differently in different cases. So it's different on BSD than it is on Linux, for example. So just use find. Find has been around forever, and it's universal. You'll be able to do anything you want with it. Well, I hope that has been exciting for you. I hope that's been interesting for you. We've learned about regular expressions and how critically to find files and how to return lines from those files when we can't remember where they are. If you have any questions, feel free to post them on the discussion boards, and we'll see you there. Thanks!